Now, there are already things called sloshing dampers, big tubs of water placed in the top of buildings that together do the same job as a mass damper, like the one in Chifley Tower. Now, Kenny here's got a model that can give us some idea of how these sloshing dampers work. OK, let's see.
We have two identical structures here, one with a damper, one without a damper. Let's give it a equal displacement, and you can clearly see that the one with the sloshing damper die out a lot quicker than the one without.
By using lots of units like this, stacked one on top of each other in a building, you get the same effect as a massive lump of steel, only these are around half the cost to install. The trouble is, each unit has to contain a layer of air, which means that together they take up a lot of expensive office space. One way around the problem is to put the water in U-shaped columns that can be stacked directly on top of each other. There's no need for layers of air because it's the friction between the water and the container that dissipates the energy. To test the idea, the team have begun the world's first full-scale trial of liquid column dampers at this communications tower in Sydney's west. PhD student Matthew Glanville is coordinating the trial, and he's put some of his damping units right at the tower's top. This tower is 67 metres tall and I'm just over halfway up. Although it's pretty calm here today, there have been days when the wind speeds reached over 100 kilometres an hour. Glad I wasn't here then. The dampers Matthew's testing can absorb vibrations in any direction. His measurements will show how well they do their job. Oh, it's pretty cramped up here.
Sure is.
20 damping units have been installed right around the tower's edge. Now I can see the water in them. It doesn't look like it's moving very much.
Not a very windy day today. Under strong winds, the water moves quite a bit. I can mimic that movement by forcing the tower, even though it's still conditions. I'll force the tower now.
Okay. Whoa! I can see the water level going and feel it too, yeah.
We've been measuring movement of the tower under wind loading for the last 3 years. And the dampers have been up for about 3 months now, and already they're showing that the movement of the tower that a person would perceive has decreased by about 50%.
Wow. The team believe their units will be just as effective in buildings and might ultimately be incorporated into the water tanks that all high-rises carry. That way even more space can be saved. Who knows, maybe one day they'll even be able to put rooftop swimming pools to another use.
Kathy Johnson with a low-cost solution to a high-rise problem. And that's all for this week. Next week on Quantum, Trouble in Paradise.